In statistics, a lot of people talk about confidence intervals, but what is a confidence interval? So in this lecture, I'm going to talk about creating confidence intervals about the mean when you already know the population standard deviation. But first of all, I'm going to talk about what a point estimate is. The value of any statistic that estimates the value of a parameter is called a point estimate. Like for example, when you have a statistic like the sample mean, we're trying to estimate the value of a parameter like the population mean. So like let's say if the population mean is 3, we're trying to get an estimate as close to that value as possible. We're trying to find out what that is, so ideally we'd want it to be 3. In my example it's 2.95. But that's the point of the sample mean, we're just trying to estimate the population mean. We rarely know if our point estimate is correct because it's just an estimation of the actual value. So because of this discrepancy between what we estimate and the actual value, we construct confidence intervals to help estimate what the actual value of the unknown population mean is. And these confidence intervals are just the point estimate, which in this case would be the sample mean, plus or minus a certain margin of error, which is defined by 3 main factors. First of all, how confident do we want to be with our estimation? Secondly, what is the population standard deviation? And third of all, how large is our sample size? So this is the equation for a confidence interval about the mean. It looks kind of complicated, but I'll talk about it. So let's say we have a distribution like this. Most of the time, we're going to want to be 95% sure. We're going to want to be 95% confident in the interval we're creating, which is this part right here in the center. Realize if we're 95% confident, we're basically accepting a 5% chance that's going to fall outside of that range. This in this case is called alpha, 0.05. Alpha is actually a much more advanced concept. It's called a type 1 error. But in my example, I'm not going to talk about that yet. Just realize that it's the area that falls outside of our range. We want our range to accommodate 95% of the values, and that 5% is what falls outside of it. In this case, it's actually split up into 2.5% because it's going to fall on either side of our 95% that we have in the center. So that's what that z, that weird z thing, is in the equation. It's just z for 0.05 divided by 2 because we have 2 tails. So what that means is in that spot we want to put the z-score for when the area in the tail is 0.025. So you might remember this horrible z-table we looked at before. If the area in the tail is 0.025, that means the area in the body is 0.9750. So if I just look that up in the table I have here that tells me the area in the body and the z-scores, I find out that we're going to want to use 1.96 for our z-score. So here when it says z alpha divided by 2, I'm just going to put in 1.96. And you can actually change that. Like, let's say you want to make a 99% confidence interval or a 90% confidence interval. It actually depends on what area is going to be, what alpha is going to be. You can change that and look up in the z table to find a different value depending on how confident you want to be. So let's go to an example. On the verbal section of the SAT, the standard deviation is known to be 100. I don't know if that's actually true or not, I just made it up. So a sample of 25 test takers has a mean of 520. Construct a 95% confidence interval about the mean. So here is our equation for the confidence interval. And I'm just going to plug things in. Notice that it's plus or minus, so I have one that's minus and one that is plus. I put in 520 for the sample mean, 1.96 for our z. The population standard deviation is 100, and our sample size is 25. So what I found here are actually called the lower bound and the upper bound. Our lower bound is 480.8, and our upper bound is 559.2. So what that means is I am 95% confident that the mean SAT score is between 480.8 and 559.2. And that is a confidence interval, which is just point estimates and margins of error.